Hi everyone, you're welcome back to Science Arena Academy. In today's video, we want to look at this Olympiad mathematics question. How can we solve this question using indices and quadratic equation? But before I start today's class, I would like you all to please subscribe to my channel and click on the notification bell to receive notification whenever I release a video. And also don't forget to click on the like button to like my video and share with your friends. And drop a comment for me in the comment box section below. Thank you. Now today, we are given a question that looks somehow impossible. That's, we have 6 raised to the power x plus 9 raised to the power x equals 2 raised to the power 2x plus 1. Now, this thing looks impossible to solve. Why? How is it impossible? Because we know that if you are given an Indica equation, we normally have this kind of equation here, we call it an Indica equation. That is indices equation. And if you are given an indices equation, there are steps in solving it. Actually, this is also an indices equation. But one thing about indices equation is that if you want to solve them, they must have the same index. For example, I have something of this kind, 2 raised to the power 2x plus 2 raised to the power x, then plus 1. This is an indices equation, whereby we can easily solve this. But now, we are not given the same indices equation that does not have the same index. How do we now go about this? It is quite easy. Now, the first thing I need to do when you want to analyze this is to analyze the right hand side of the equation. From here, I have 6 raised to the power x plus 9 raised to the power x equals to this. Now, according to the law of indices, we believe that if I have x raised to the power a multiplied by x raised to the power b, I will be having x raised to the power a plus b. Now, this same law can be applicable in this place here. Now, if I apply the law here, then I can easily split this like this. That's 2 raised to the power 2x multiplied by 2 raised to the power 1. That is what I'm going to be having for this. Now, again, coming back to these points, I have 6 raised to the power x, 9 raised to the power x equals this. I can also apply the law of indices. According to the law of indices, if I have x raised to the power a, everything raised to the power, x raised to the power a times x raised to the power times b, this thing can easily be written like this: x raised to the power a raised to the power b, or x raised to the power b raised to the power a. This is the law of indices because if I have 2 power, I can easily multiply the 2 power to get this. I'm going to be applying that same law here, whereby I can easily say 2 raised to the power 2, 2 raised to the power 2, everything raised to the power x multiplied by 2. Now, here I will be having 6 raised to the power x plus 9 raised to the power x equals to 4 raised to the power x times 2. That is the next step. Now, I can easily remove this. Now, what is now the next step in this place? The next step that we're going to use to solve this is to divide all through by 4 raised to the power x. Now, if I divide this by 4 raised to the power x, this side by 4 raised to the power x, while this by 4 raised to the power x, I will be having this, whereby I can also apply the law of indices in solving this. How do I apply the law of indices in solving this? Now, coming back to this, if I have, according to the law of indices, if I have a all over b, everything raised to the power x, the law of indices said that this same thing can be written as a raised to the power x all over b raised to the power x. That means I can turn this into this. The same thing, coming back to here, I can write this as 6 over 4, everything raised to the power x. Now, 6 over 4, then I can also write this also as 9 over 4, everything raised to the power x, everything equals to 2. That is my next step. Now, how do I go about this? I think there is something I can divide this. What I'm trying to do is that I want to make sure that this value that is having raised to the power x are equal. They are of equal index. Now, I've tried to make sure that all my index are found in the right hand side of the equation. This is my index, this is another index. But how can I solve this? 2 can divide this. If I divide this by 2, I will be having something of this kind, whereby I'll be having 3 all over, because 2 here I'll be having 3, 2 here I'll be having 2, so I'll be having 3 all over 2, everything raised to power x, then plus, I can apply the law of index here. This 9 is a perfect square, also 4 is also a perfect square. You know that 9 is the same thing as 3 square, while 4 is the same thing as 2 square. Now, I can easily remove this by writing 3 raised to power 2 over 2 raised to power 2, everything raised to power of x. Now, equals to 2. Now, I have 3 all over 2 raised to power x, then plus, if I go to this place here, I can easily write this as 3 over 2, everything into square, everything into raised to power x equals 2. Now, coming back to the same law of indices that I gave to you, that if we have a raised to power b raised to power a is equals to a raised to power ab. Now, we can apply this back as well, whereby I'll be having 3 all over 2 raised to power x plus 3 all over 2 raised to power 2 multiplied by x will be giving me 2x. Now, everything equals to 2. Now, I can as well return this back. How do I return it back? From this point here, this thing can be written as 3 over 2 raised to power x plus 3 all over 2 raised to power x into square. By returning this back to this and this one to what? To replace this side, then everything equals 2. Now, I've been able to write this in terms of what? Equal index, which is related to the same way of solving Indica equation. Now, how do we now finalize this Indica equation? If I want to finalize this Indica equation, then I'll try to convert this Indica equation into a quadratic equation. Now, in converting it into a quadratic equation, I'll be having, let's assume, 3 all over 2 raised to power x to be equals to, let's say p, anything. Now, if 3 all over 2 x is equals to p, let me try to remove this. I'll be having something of this kind. 3 over 2x is p. Then from here, I'll be having, now, so if I have this, we have 3 over 2 raised to power x equals to p. Now, returning that back into this equation, I'll be having this, where this is my p, plus p into square, everything equals to 2. Now, what is the next thing? What will I do next? The next is that I'm going to rearrange this to form, in form of this equation, ax squared plus bx plus c equals 0. Now, in rearranging this equation, this should be giving me p squared plus p. Now, this should be returning back to this side to become minus 2 equals 0. Now, I've turned it into quadratic equation, then I can easily solve this by factorization. If I want to factorize this, I'll be having what multiplied that will give me minus 2. If I add it together, it's going to be giving me plus 1. I think the factor of this equation is 2 or minus 1. That is the factor of the equation. Now, I can easily join this by factorization. That p squared plus 2p minus 2 equals 0. Now, p is common to this. If I remove p, I should be having p plus 2. Then, I should be having minus 1p plus 2 equals 0. Then, my final answer should be p plus 2 and p minus 1 equals 0. Now, where my p will be equals to negative 2 or positive 1. That is the value of my p. Now, if you have already gotten your p, the next value is now how can we get our x? Because the question said find x, not find p. But I've been able to get p. Now, one thing I want you to understand that you are going to substitute this your p value back into this thing here to solve. Now, if I return back to this place, I can easily remove this. I think I'm done with this. Now, if I return back here, this is my major equation that 3 all over 2 raised to power x equals to p. Now, if 3 over 2 is equals to p, 3 over 2 raised to power s is equals to p, and I've gotten my value of p, now when p equals to minus 2, now what can we do next? If I substitute this, I'll be having 3 over 2 raised to power x equals to minus 2. But I want you to understand that it will be difficult for me to analyze this Indica equation. Sometimes you might have two values of x, whereby I'm getting two values of p here to be equals to minus 2 and 1. But it might be only one single value that has the solution of this equation. What is that value? Now, returning yourself back into this place, if I say 3 over 2 raised to power x is equals to minus 2, now returning it back, I'll be having, using when p equals to 1, now I'll be having 3 all over 2 raised to power x equals to 1. Now, by analysis, I can easily write this thing as 3 all over 2 raised to power x, which is equals to 3 all over 2 raised to power 0, whereby my x equals 0. Now, let's try to resolve if we are going to get this equation right or not. From here, let's substitute back. The equation said, if I have 6 raised to power x plus 9 raised to power x, let me try to bring it here back. 6 raised to power x plus 9 raised to power x equals to 2 raised to power x plus 1. Now, if x is equals to 0, let's see what we're going to get. Now, let's substitute x to be 0 in this equation here. I have 6 power 0 plus 9 raised to power 0 equals to 2 raised to power 0 plus 1. Now, anything raised to power 0, according to the law of indices, a raised to power 0 is equals to 1. Automatically, this should be equals to 1 plus 1, which is equals to 2 raised to power 1. Whereby 1 plus 1, I'll be having here is 2 and here is 2. Which shows that since the left hand side of the equation is equal, then this equation 6 raised to power x plus 9 raised to power x must be equal to 2 raised to power x plus 1, which is highly correct. Thank you for watching this video. Please don't forget to subscribe to my channel and click on the notification bell to receive notification whenever I release my video. Thanks.